What's up, your boy MJ here, looking at some parallelograms. So, and area. Okay, so let's start with a rectangle. Okay, quick review. So if I make my rectangle here, and let's make actually a rectangle, not a square. There's my rectangle, okay? So finding the area, that is pretty easy by grade 5, hopefully. And we can simply, where's my tools here? There we go. We can simply, there we go. Look at its, I mean, we count the squares, 1, 2, 3, 4, 5, 6, 7, 8, right? And it's gonna be 8 units squared. And grade 3 and 4, we start to learn a formula for that, which is we look at the length times the width, whatever one you wanna call, whichever one, doesn't really matter, and you multiply them. So length times width, or I really like to start getting even little kids to start thinking of it as base times height. But either way, it ends up being 4 times 2, and that equals 8 units squared. Okay, and don't forget the squared, because why? Because you are literally making 8 squares. 1 square, 2, 3, 4, 5, 6, 7, 8 squares. Okay, they're square units, 1 by 1 squares. Okay, you can also think of it as the line is 1 dimension. So if I say this is 9 units long, there's sort of an imaginary 1 there, right? Because it's 1 dimensional. Whereas a shape placed on, in this case, a grid, is going to be units squared because it has 2 dimensions, length and width, or base times height, whatever it is you want to call it, okay? So that's rectangles review, okay? Now, counting squares is great, unless all of a sudden you have a shape that is, well, let's just change this one. If I make it not on the lines, but still a rectangle, well, then I can't count squares anymore because I've got, okay, 3 full squares and I've got all these part squares. So that's why we need a formula to work on shapes that are not obvious, right? Counting squares works if it's a perfect sort of a whole number area, but as soon as you get into the little bits and pieces, then it gets too complicated, okay? So that's why we need a formula. Okay, so rectangles, get out of here. How do I reset this screen? Reset, zoom to fit, clear, I don't know. Whatever, let's just erase stuff. All right, let's use the space over here. So now we get into parallelograms. So the rules for a parallelogram are pretty simple. The geometric rules, that is. It needs to have 2 sets of parallel sides, needs to be a quadrilateral, needs to be a polygon. So all that means is it needs to be closed. So for example, if I go like this, and then I go like this, and then I stopped right there, it would not be a polygon, because a polygon must be closed, okay? To be a quadrilateral, it has to have 4 sides. So if I clicked right now, it would have 4, well, let's do it. It has 4 sides, so now that is a quadrilateral. It is a shape because it's 2-dimensional. It is a polygon because it's closed. And it is a parallelogram because it has 2 sets of parallel sides. Specifically, this sort of, let's call this the base, okay, because it looks like it's sitting flat, although any side can be the base, but let's just call this the base for now. So the base and its opposite side must be parallel and equal length, which they are, and the other 2 sides must also be parallel and equal length, which they are, and opposite angles would be equal, okay, which we're not really worried about yet in this unit, but it's just another sort of fact. So a rectangle is also a parallelogram because it is a quadrilateral, it is a closed polygon, it does have 2 sets of parallel sides and opposite angles are equal. So it's also a parallelogram, but when you talk about parallelograms, putting in a rectangular square is kind of cheesy, and really we think of these slanty boys as being parallelograms, okay? But really, rectangles and squares are also parallelograms. Okay, on to this parallelogram. So how do we find its area? Well, things are a little bit different. I'm going to put on the measurements here, but I'm not going to put on the area yet. Actually, you know what? Let's put on the area. Click on the, click on the area. Let's find out what it is, and then let's find out how we got it. So it's saying 12. Let's find out let's find out how they found it. The computer's usually right. In this case, it is once again. Can I drag it out of here? I'll put it way over here. Okay, so those are our side lengths, 3.2, 4, oh no, and also 3.2. Now, if I use my old formula, if I use that rectangle formula, let's see if it works. So I'm going to say length times width was the formula for area of rectangles and squares. Let's see if it also works for parallelogram. Well, in this case, my length, I'm gonna say is 4, and my width is my other side, 3.2. And when I multiply 4 by 3.2, do I get 12? No. I get 12.8. So this formula does not work for parallelograms, okay? Because I got too much. And I didn't get 12 in any case, so I know it's wrong. So let's find out what the formula actually is and how you find it. The way this works is, well, you know what, I'm going to go backwards. Usually I just show you the proof first and then the formula, but this time I'm going to go opposite. The formula for area of parallelogram is base times height. Now that sounds very similar to what we talked about with rectangles, but width and height are not really the same thing. In a rectangle they are the same thing because it's just this dimension here. But in a parallelogram they're actually different. So I'm going to go to my segment tool up here, and I'm going to draw a line coming out of the top or the base, whatever you want to call that, going to the bottom, and I think if I hold shift it'll make it stay straight. Yeah. It needs to be a straight line coming out at a 90-degree angle and going up or down the shape. Okay? Now when I measure that line, it should say 3. It does. Okay? And if I just count the squares, I'm just going to get my draw tool back. If I just count my squares, I can see it's 3, right? A height of 1, 2, 3. So this is a little different. I'm not using the side length. Side length will help me with perimeter. It does not help me with area. So in this case, the base is 4 times the height, which is 3, not the side length. If you use the side length for a slanted parallelogram, you're going to get the wrong answer. It's wrong, okay? If your parallelogram, wink, 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 is a rectangle or square, well, the height and the side length are the same, so it's not going to matter. But here you can see if I do 4 times 3, that equals 12 units squared. And that works perfectly, okay? Now, why does that work? Here is why. What's really happening with this formula when I do base times height is you can imagine, and on your test you could certainly draw this, that I'm taking this away. I'm taking this triangle off the edge away, and I'm going to actually move it over to here. So this triangle is going to be reproduced over here. I'm not changing the area. I'm just taking a chunk of area and moving it to the other side of the shape. Why would I do such a thing? Because now I've made a rectangle. I've made a 4 by 3 rectangle. Because the side length is no longer 3.2. 3.2 was the side length when it was slanted, because slanted lines are slightly longer than straight lines, okay? But since I moved this triangle to the other side of the parallelogram, well, now I've made it a rectangle, okay? But I didn't change the area. I just took this chunk and moved it over here and turned it into a 4 by 3 rectangle. And what's a 4 by 3 rectangle's area? 4 times 3 is 12, okay? That's why base times height works for parallelograms, but you must use the height. You cannot use the side length. It will be wrong. The only time you can use the side length is if it's a rectangle or a square, which are technically also parallelograms, okay? Now that formula will always work, and the moving the shape works on, like, it's easy to understand with some parallelograms, but if you have like a really, really, really weird parallelogram, it's harder to imagine moving parts of it, but in this case, it's still going to work. The formula base times height will still work. And I can just kind of come out here and make my height out in this shape, okay? And then in that case, my base of this weird parallelogram, I'm going to use the top this time, okay? So the base is going to be 1 unit, and the height's going to be 1, 2, 3, 4, 5, 6, 7. So in this case, it's base times height still, even though it's a weird-looking parallelogram. And in this case, it's going to be 1 times 7 for a total of 7 units squared. And just to prove to you that I'm not doing it wrong, if we go back to area tool, we'll get the area equals 7. Okay? So base times height will always work. And even if it's hard to draw, like I could still split this up and move chunks of area, and I could make a rectangle that's 7 by 1. It's just not as clear to see as it is with this more sort of traditionally shaped parallelogram. But the formula will work on any, just like the formula length times width works for rectangles and squares. Base times height works for any parallelogram, but you must use the height, not the side length. Okay? That's it. So hopefully that helps with parallelograms. And peace. I'll do triangles next.